Good morning, students. I am Dr. Shanmukh Kuchpal. So, this is a third part of a continuity and a differentiation. I am solving all possible 4-mark questions from part E section. So, let us begin with this example. Find the value of a k so that the function f is continuous at the indicated point. So here it is a continuous at x equal to 0, so we can write this as f of 0 equal to LHL equal to RHL. So further here x not equal to 0 they have given. So here we don't come across like LHL and RHL. So it is a not equal to and equal to is there. So directly we'll take this as f of 0 equal to, it is a limit x tending to 0 f of x. Because it is a not equal, then we have particular function here. So further f of 0 at x equal to 0, the value is a k. So I take the LHS part as a k, and then I write the limit as it is. Further x is tending to 0 as it is, and f of x, when it is a not equal, the function is 1 minus cos 2x divided by 1 minus cos x. Further we'll take k equal to limit x is tending to 0, 1 minus cos 2x, we take it as a 2 sine square x whole divided by 1 minus cos x. So we'll keep as it is 1 minus cos x. So further we'll simplify it. So limit x is tending to 0. So 2 we keep as it is. I use a trigonometric identity. Sine square theta plus cos square theta is 1. So similarly sine square x we get it as 1 minus cos square x, like this. The denominator it will remain same. So further limit x is tending to 0 as it is, 2 as it is. So numerator 1 we treat it as a 1 square minus cos square, a square minus b square. Then we can write this as a plus b, 1 plus cos x, and one more 1 minus cos x whole divided by, it is 1 minus cos x. So further 1 minus cos x, 1 minus cos x from a numerator and denominator get cancels. So we get a k equal to, now wherever x is there we have to replace it by the limit 0 here. Then we get this as 2 into 1 plus cos 0. Cos 0 is 1. So further we get this as 2 into 1 plus 1, 2. So k value we get it as a 4. So like this we have to find the value of a k. So let us discuss one more example here. For what value of a lambda is the function defined by f of x? See, when x less than or equal to 0, lambda times x square minus 2x. When x greater than 0, 4x plus 1. Continuous at x equal to 0. What about continuity at x equal to 1? We have to discuss it. So now we will discuss at x equal to 0. So we get f of 0 when equal to 0 means we have to take this one. So we get lambda times x is 0, 0 square is 0 minus 2 into 0, 0. So answer we get it as a 0. So this is f of a 0. Then we'll take a RHL, right hand limit, we get limit x is tending to 0, RHL is greater than value, greater than means we have to consider this one, so we get this as 4x plus 1. Now wherever x is there, we have to replace it by 0, so we get 4 into 0 plus 1, so we get this answer as a 1. So we'll observe that f of 0 is 0 and RHL it is a 1, and this f of 0 and RHL, they are not same here. Therefore we can say that f of x is not continuous at x equal to 0, and thus no value of a lambda, no value of lambda at x equal to 0 here, no value of a lambda at x equal to 0. See, this part is over at x equal to 0. Now we have to examine what about this continuity of a function at x equal to 1. For this, at x equal to 1, so at x equal to 1 means it is a greater than the value, greater than, equal to 1 is it is a greater than 0, so we have to consider this one. So we get this as f of 1 equal to 4 into x, 4 into 1, 4 plus 1 equal to 5, we get it. So now limit will consider limit x is tending to 1 f of x. So this is equal to limit x is tending to 1, f of x is 4x plus 1. So we'll observe that x equal to 1, 4 plus 1, so we get this is equal to 5. We observe that f of 1, and see, limit at x equal to 1 f of x, it is a same value, this is equal to 5. Therefore we can clearly we can write this as f of x is continuous at x equal to 1, and f of x for any value of lambda, f of x is continuous. So dear students, we observe that at x equal to 0 limit does not exist, whereas x equal to 1 the limit exists. So in this session, so last sessions I have solved numerous examples on continuity, 4-mark questions. So possible all previous year questions I have solved it. So practice all these examples. Thank you very much for watching this video.